In our lab example, we have a hydrate with a given molar mass of 232.93 grams per mole. Now what we need to do, using the accepted value for the percentage of water which in our lab experiment was given as 46.40%. So we need to use this to determine how many moles of water are in this hydrate, and this will help us develop our hypothesis. So the formula tells us the accepted percentage of water, H2O, equals the molar mass of water and this is the molar mass of water in the hydrate divided by the molar mass of the total hydrate. So we know several things at this point. If you calculate the molar mass of a single water molecule, it's approximately 18.02, and we already know the accepted percentage of water. We already know the molar mass of the hydrate, and we can figure out the molar mass of a single molecule of water, so we're basically looking for a coefficient that would go in front of the molar mass of water. Okay, some unknown. So we know that the accepted value of water is 46.40%. Oh, and this is times 100 in order to get percent. Okay, and we know that there's some unknown coefficient here, we'll just call it X, that goes in front of water. And we know the molar mass of one molecule of water is 18.02. If you need help on calculating the molar mass of water, then you can look at one of our previous videos. The molar mass of the hydrate is given as 232, forgetting the 100% again, 0.93 grams per mole. So what you need to do is solve for X, basically, and that will give you the number of moles that we expect. Okay, or the accepted number of moles. Of water in our hydrate. Okay, so solve for X. That's basically it.